Okay, good morning. First, I'm going to explain my assignment for the chapter 4 and chapter 5. In the chapter 5 is how to use dot plot, stem, and leaf plot. So, how to make a dot chart. While constructing a dot diagram, data points are stacked in a column over a category. The height of the column denotes the frequency of observation in a given category. So, first, I'm going to explain the dot plots. Listed below is the number of each type necklace were sold last 12 months at the Siblings Jewelry Store. And here are the type of each, which is titanium, beaded and chain. For the first month is titanium sold for 8 pieces, beaded for 10 pieces, and chain for 5 pieces, and so long until the 12 months. So first we calculate the frequency for each value in the data, and we sort from the smallest number to the largest value. And next, we express the probability in decimals by dividing the number of desired outcomes by the number numerator and the total number of outcomes. And the formula is probability equal number of desired outcomes divided by total number of outcomes. So dot plot chart is the categories of dot diagram. Given below are the numbers from 5 to 38, where 5, 12, 18, 24, 26, and 38 occur one times. 8, 10, 22, 28, and 35 occur two times. 15, 25, and 32 occur three times. 30 occur four times, and 20 occur six times. As you can see in here, the dot plot, and the 20 is more higher because it occurs six times. So we draw the dot plot by creating a horizontal number line and then making points above the data values according to the frequency type. The dot diagram given above are represent the total number of data points and how the data points are distributed among the certain categories. And next, we have I'm talking about stem and leaf plot. Stem each leftmost digit of the number, and the leaf is the rightmost digit of the number. So the method of making stem and leaf plots, I'm still gonna use my business data for the necklace tool for the 12 month. To make the stem or the leaf plot must be sorted in an ascending order and then make the above numbers into components, namely stem and leaf. The 10 number is for stem and the unit number is for leaf. Then we spread the tens number and unit number with a horizontal line sign as a separator sign. So after I ascending the largest to, the smallest until the largest number, I got 5, 8, 10, 12, 15, 18, 20, 22, 24, 25, 26, 28, 30, 32, 35, and 38. So here are the stem and the leaf. The first and the second numbers are unit because it's just one number, which is 5 and 8. And the third number is 10 and is split into 1 and 0. The number 1 is 10, so it becomes the stem. And the number 0 is unit, so it becomes the leaf. Fourth number is 12, and we spread into 1, the stem, and the 2 is for the leaf. For the fifth number, 15, we spread into 1 stem, and then 5 for the leaf. For the fourth number, which is 10, 12, 15, and 18, have the same stem, which is 1. So the unit number is placed on the same leaf row. It's also gonna use for the stem for the 2 units and for the 3. which is the leaf is 0, 2, 4, 5, 6, and 8. And for the stem tree, the leaf are 0, 2, 5, and 0. And next, I'm going to explain the chapter 5, which is how to use classical and empirical probability. The classical probability is based on the assumption that the outcome of an appropriate approachment are equally likely. Using the classical viewpoint, the probability of an event zero, assigning probabilities happening is computed by dividing the number of favorable outcomes by the number of possible outcomes. The formula is probability equal number of desired outcomes divided by the total number of outcomes. The probability range from 0 to 1. The 0 is impossible to occur. 1 is even will surely happen. And here are the examples. Xingbing's jewelry store has given the opportunity to earn 50, 18, 100, 150, and 200 discount for people who purchase a particular item. The problem is that to get this discount, people have to buy the particular item at least 100. So what are the probability to win? First of all, we have to define the sample space, which is 15, 18, 100, 150, and 200, which is 5. Second, we have to define the quantities of favorable outcomes to the event. These are the quantity greater than 100, which is 150 and 200, and the total of is 2. So probability is equal to divided by 5 is 4. Next is empirical probability. So in a given year, here are the sold of each type of necklace. The table is in here is the data shows from the first month and 12th month of the each type that sold. And if the probability of the certain necklace is remain constant, I find the probability that the next necklace seen is, and the total of the data is 1830. So here are the formula for empirical and example. So the probability is E equal F divided by N. So I'm going to search by one each type, which is titanium first. 270 and 2 divided by 1830, which is 33% or 33.4%. And the bid rate is 219.2 divided by 1830 and is equal 35% or 35.9%. And the chain is 249 divided by 830, 13 is equal 30% or the 30.6%. And that's other result for empirical probability for my business data. So thank you for the listening and attention. And that are my business data for the method of dot plot, stem and leaf plot. Also the probability, which is